Once we are done with the geometry part, we can move now to the mesh. In this step, we will divide the domain into small control volumes, and we will play with the quality of the mesh if you want. So we can increase the number of elements or decrease it, test the number of elements required to give good results, etc. So this is one of the most important parts in CFD, because if you don't have a good mesh quality, and we'll see how we can assess the mesh quality, you cannot have good results, and you might have divergence or unphysical results. Okay, so you double click on mesh after you are done with the geometry, and this window will open for you. So this is the space we considered in the geometry part. Now, what we will do, as we said, we will divide it into control volumes. Now, the first step will be to, if you want to name the parts, okay? Naming the parts is essential, because we will see that we can do different if you want mesh strategies. So we can, for example, select a face size for each part different than the other. Also, we need to do the name selection, which means we name each part, because after in the setup, maybe you want to impose boundary conditions, of course, on each part. So you should know, you should identify this part by its name. Okay, so we'll start first with what is called name selection. To do this, okay, first you you select this tool. This tool is for selection of a face. Okay, so I can start with naming my parts. Now, here, for example, we have 4 walls. Okay, you might say that if all walls will have the same condition, so you have same heat flux through all of the walls, no need to name wall 1, wall 2, wall 3, wall 4. Because at the end, what is important for me, if no difference between walls, I can select the 4 walls. Okay, in case you're, let's say, this is an internal office, and all of these walls are partitions. Maybe you can consider then that the heat flux is nearly 0, so it's a good strategy to select all of them. In case each wall is subjected to different condition, you need to name them separately. Okay, so if you want to name them separately, you select the first one, you do right click, and you select then create named selection. And now, for example, you can say it's wall 1. Okay, so this is wall 1. Now, if you change your mind, you don't want this name selection anymore, all you have to do is to do this here. Once you start to name your parts, you will have them under name selection. So if now you want to take the 4 walls as one name, walls, you can just say, I want to delete this. So you do right click, delete. And if you want to select all walls together, all you have to do is to press Control. So you press on Control and you select all faces. Because if you don't press on Control, once you do a new selection, the other one will be canceled. Okay, so I will now, for example, I'm not pressing on Control. If I do this, I will not have this anymore. So whenever you want to do multiple selections, just click on Control and do your selections. So 1, 2, 3, and 4. These are our 4 walls. Now, right click, create named selections. I can just put walls, and okay. And now I can make sure that it's 4 faces. I just click on walls. You can see here's the details. You have 4 faces, and you can see them. So if you select this tool, you can turn your space and make sure that these are the 4 faces, which are the walls. Okay. Now we have the ceiling. So for the ceiling in general, we have a lighting load. So we can put it as a distributed load. And you can know the value from ASHRAE recommendations. In general, for example, it's around 10 watt per meter square. So now I select the ceiling, I do right click and again, create name selection. This is my ceiling. Now I can consider the floor. So this is my floor. Now I want to select my occupant. Okay, my occupant, if you remember, we suppressed the body because we are just interested into the external surface, and you can do a small zoom with this tool. You have here 2 surfaces to select: the lateral surface of the cylinder and the top surface. So you will select this tool, the face selection, and now press Ctrl. You select the first face, you select the second one. Okay, so our occupant is made of 2 surfaces. Now I do right click, create name selection, and this is the occupant. I still just have the inlet and the outlet of my space. So now I can select, if you remember in the geometry, we did imprint faces so that we will be able to select the inlet and outlet separately from the wall. So for example, this is my inlet. And this is my outlet. I just turn with the tool, with the turning tool. Again, I do the face selection and I just name it. Now, sometimes if by error you named the same face 2 times or you selected 2 times, it will give you a warning error. Okay, so you cannot select the same face 2 times for 2 different name selections. So now we are done with the first part. We have the names of all our parts: walls, ceiling, floor, occupant, inlet, and outlet. Now, to generate your mesh, you can just, as a first trial, not do any strategy. And by default, use the generation features of ANSYS. And after doing this, we'll talk together, we'll see some strategies to enhance this meshing. So if you just take by default the mesh settings, you can just right on mesh and select generate mesh. Okay. Now we'll see how to assess the quality of the generated mesh and how we can improve it to have a better mesh. So we'll wait some time. Here you can see the processing of the meshing step. So it will take some time to divide the space into control volumes. So as you can see here, for example, by default, the ANSYS Fluent has selected tetrahedral elements here. Why it's not a structural grid? Why ANSYS Fluent didn't choose rectangular elements? Because as you can see here, you have a cylinder, you have curvature. Whenever you have a curvature, you don't have right angles everywhere, the rectangular mesh is not appropriate anymore. Okay, so in general, tetrahedral elements are used when you have curves. Okay, because they will allow you to, if you want to trap your curves in a more efficient way than rectangular meshing. Okay, so because you don't have, for rectangular mesh, you don't have straight lines to do if you want, and you don't have right angle to do it. So it will not be efficient to use a rectangular mesh when you have curves. So this is why tetrahedral elements are more efficient in such case. And now, how to, if you want to change the mesh settings, and what are the strategies that can be done to enhance the mesh quality? This is what will be done now. So if you enter first, if you select mesh, you can see by default what are, if you want, the strategies used by ANSYS Fluent to do the mesh. Okay, so you have, for example, the sizing, the quality, and for example here, you can impose the element size. We'll see how you can see the quality of your mesh. So you have different, for example, you have different tools to assess the quality of a mesh. Okay, we will go over the main ones. So here, when you press on mesh metric, you have, for example, all of these are characteristics of the mesh quality. Mainly the main two important ones are the skewness and the orthogonal quality. Okay, I will explain in brief what are these. Now we can see all other characteristics if you want, and any characteristic you are interested in, you can just enter help in ANSYS. It will explain for you what is this quality and what is the value recommended for it. In general, we control the skewness and the orthogonal quality. So first, concerning the skewness, what does skewness mean? So first, the skewness of a grid is an indicator of the mesh quality and suitability. Larger the skewness, okay, we don't have to have, it's not good to have very large values of skewness, because large skewness compromises the accuracy of the interpolated regions. And we can define skewness as the difference between the shape of the cell and the shape of an equilateral cell of equivalent volume. So a general rule is that the maximum skewness for a triangular or tetrahedral mesh in most flows should be kept below 0.95. So here they will give you, as we'll see together, what is the minimum skewness in your domain, what is the maximum skewness in your domain. So you should verify that the maximum skewness in your domain does not exceed 0.95. And it's recommended also that the average value is less than 0.33 to have a good skewness. Okay, so you should verify here, for example, you have the minimum, you have the maximum, and you have the average. Already, our domain, our geometry is relatively simple. So here will not face problems, but sometimes if you have very complex geometry, let's say if you replace the occupant instead of a cylinder by a real thermal mannequin, with curvatures, etc. This will complicate a lot the meshing, okay, because you have to consider all curves of the human body, let's say the different parts, the head, the torso, the arms, the feet, etc. So you need to follow all curves. This will complicate the mesh, and maybe you will have some zones with relatively high skewness. So you should try to do some strategies, and we'll see together what can be the strategies that can enhance the quality. So here it's already good. The maximum is below 0.95. The average is also below 0.33. So we are on the safe side for the skewness. Another important criterion for the mesh quality is the orthogonal quality. So here also you can select it. This is the orthogonal quality. It's a complex number that needs mathematical tools to calculate it. But what you should know, okay, that the minimum orthogonal equality should not be below 0.1. So for the orthogonal equality in opposition to skewness, higher is the orthogonal equality, the better the mesh quality. Okay, so in summary, as I can say that the orthogonal equality is computed with vector mechanics. Calculations are done by using the face normal vector and the vector from the cell centroid to the centroid of each of the adjacent cells, and the vector from the cell centroid to each of the faces. So it's a complex calculation. You don't have to know its detail. Just if you want, you should know that I should maintain a minimum value above 0.1, and also I should have an average value as high as possible. And if I approach 1, this is very good, because if the average is closer to 1, then my mesh quality is better. So for example, here in this space, the minimum is 0.25, which is fine because it's above 0.1. The maximum is close to 1, it's 0.98, and the average is 0.77. So I can try to increase the average. So higher is the average, the better the mesh quality. So let us try to do some strategies together to see if we can improve the average value of orthogonal equality. One of the main strategies will be to reduce the face size. Okay, so if you use smaller elements, in general, this will enhance your mesh quality. How to do this? So we need to implement some strategies to improve the mesh. To do this, we go to mesh, we do right click, and we put insert. The first strategy is sizing. Also, if you want, you can play with the method of mesh. So what is the type of elements you want? You can impose the type of elements you want: triangular, tetrahedrals, etc. Okay, so here when you select sizing, in sizing you have first to determine what are the faces you want to specify the element size at. Okay, so to do this, you have two possibilities. You can do geometry selection. So again, for example, let's say I want to size the walls. I want to impose on the walls, for example, a size, let's say 5 centimeters for the element. Okay, the edge size. So I can put geometry selection. I select again the walls, or instead of selecting again, since I already named my different parts, I can just click on named selection and I will select walls. Okay, so I want to size the walls. Okay, I want to impose a certain size. So what I will do then for the sizing, I will select here walls. Okay, and now I can specify the element size that I want. So I want to put the size needed. So here